Hello, good morning. So, welcome back to my channel. Our topic for today is all about integrals of algebraic functions, which is leading to trigonometric substitutions. So, this time we're gonna solve an algebraic integral in terms of trigonometry. Okay? So, we are trying to substitute trigonometric functions into our algebraic functions. Now, when do we use this one? So, we will use this one if we encounter these three algebraic functions. So, if we have the square root of a squared minus u squared, the square root of a squared plus the u squared, and the square root of u squared minus the a squared. Okay, these three algebraic functions obviously has a radical symbol. Okay, so we are trying to substitute trigonometric functions to this one to eliminate this radical symbol by applying the following trigonometric formulas. First, let's have uh, the value for cosine squared. The cosine squared theta, that is equivalent to 1 minus sine squared theta. Okay. Next, we have the tangent. The tangent squared theta, that is equivalent to secant squared theta minus 1. And last, we have the secant squared. Secant squared theta, that is equivalent to 1 plus tangent squared theta. So we will be using this trigonometric formulas. So for these topics, it has three different algebraic functions. This one is called or known to us as the case 1. When we see this one, we will use case 2. And when we see this one, that is case 3. Case 1 focuses on substituting sign. So for our u, okay, we will substitute a sine theta. For case 2, our u, we will substitute a tangent theta. For case 3, our u, we will try to substitute a secant theta. Okay? So, we will now have a trigonometric equivalent. Okay? So, deriving this one, derivative of the u, that is a cosine theta d theta. The derivative of this u, that is a secant squared theta d theta. The derivative of this u, that is a secant theta tangent theta d theta. Okay, so this is the technique. Why are we doing this so? Again, as I have mentioned, we are trying to eliminate this radical symbol right here. Let's have an example for case number 1. So for case 1, we have the square root of a squared minus the u squared. So for case 1, we're going to substitute for the value of this u as a sine theta. The square root of a squared minus, we have the a sine theta squared. So we now have a squared minus a squared sine squared theta. Notice we could factor out a squared from these two terms. We now have a squared 1 minus sine squared theta. In algebra, we could split the radical symbol from two functions, recalling square root of ab, that is equivalent to the square root of a square root of b. So we now have the square root of a squared and the square root of 1 minus sine squared theta. Okay, notice we could cancel the square root, so we now have just a outside. the square root of, what is 1 minus sine squared? If we recall the trigonometric formula, 1 minus sine squared, that is cosine squared. And notice we could cancel again the radical symbol and then the squared. We now have a cosine theta. Now notice we have eliminated the radical symbol. Okay, so as much as possible we will use this topic the moment when we see radical symbol, not just only with the square root. We could have other radical symbols. We could have 5 halves, 3 halves, 7 halves, and so on and so forth. Okay, now we intend to do this one to use trigonometric substitution, but later on in our final answer we will be needing to bring back this trigonometric function into algebraic function, since our original problem or our original integrand is in terms of algebraic. So how do we convert this one? We are going to use right triangle method from the Pythagorean theorem. Okay, so let's have the Pythagorean method. Okay, so we are going to bring back our trigonometric functions in terms of algebraic functions by the use of these right triangles. Okay, so constructing our right triangle, how? So in our case number 1, we have substituted as u as equivalent to a sine theta. U is equivalent to a sine theta. Notice if we divide both sides with a, therefore sine theta, that is equivalent to u over a. When referring to sine theta, this u over a represents what? So sine is opposite over hypotenuse from the SOHCAHTOA. So this sine theta, the u is opposite, u is here, and then the hypotenuse is a. Therefore, using Pythagorean relationship or the Pythagorean theorem, this side right here, that is the square root of a squared minus the u squared. Okay, so as you can see, this is our algebraic function right here. Okay, now going to case 2, we've used u as equivalent to a tangent theta. U as equivalent to a tangent theta. Dividing both sides with a, we now have tangent theta equivalent to u over a. So when we are dealing with tangent, u, this one is the opposite, and a, that is our adjacent. Therefore, this part right here, the hypotenuse will be the a squared plus the u squared. Seems familiar? This is our original algebraic functions. Now, lastly, let's have the second theta. Okay, so case number 3, u is a second theta. Now, if we divide both sides with a right here, we now have second theta as equivalent to u over a. So, second theta came from the inverse of the cosine theta. So, for the second theta, that is hypotenuse over adjacent. So u is our hypotenuse and a is our adjacent. Therefore, this part right here of our triangle, that is equivalent to u squared minus a squared. Seems familiar? Okay, this is our original algebraic functions. Okay, so we're going to use this method to convert this algebraic to trigonometric, and we're going to use this method to convert a trigonometric in terms of algebraic. Okay, so again, since our original function is in terms of algebraic, our final answer will be in terms of algebraic functions. Okay, let's start with the examples. Okay, let's have number 1. The integral of the square root of 9 minus x squared over x squared dx. Okay, so the hint that we are going to use trigonometric substitution is this one. So we've seen the square root of 9 minus x squared on the numerator. So we need to find the following values for a squared and for the u squared. Okay, for the a squared, it is obviously 9. Therefore, a is the square root of 9, which is 3. For the u squared, this is obviously x squared. Now, the u is x. What am I going to replace with our u? So, we have 9 minus x squared. That is a sine theta. Okay? So, make sure that you've memorized all the formulas when we have a constant minus a function that is to be substituted with sine theta. Okay. So, let's have the value of a. The value of a is 3 sine theta. And we will also be finding out the derivative of x. The derivative of x, which is 3. The derivative of sine, which is cosine theta d theta. Now let's try to substitute these trigonometric values to our algebraic value. So let's have integral of the square root of 9 minus, what is our x? So we have 3 sine theta, square this one, over the denominator x, which is 3 sine theta squared. Okay, and our dx, we have 3 cosine theta d theta. Okay, now let's try to evaluate this one. We now have the square root of 9 minus 9 sine squared theta over 9 sine squared theta. We have the 3 cosine theta d theta. Notice we could factor out 9 here. So we now have the square root of 9 and the square root of 1 minus sine squared theta over 9 sine squared theta, and we have the 3 cosine theta d theta. Okay, so square root of 9, it's 3 times 3, we have 9. So we have 9 over with, still have 9 sine squared theta. The square root of 1 minus sine squared. 1 minus sine squared is an equivalent of cosine squared. And we have our cosine theta d theta. Notice we could cancel 9, square root and squared. So we now have here the integral of cosine theta times cosine theta, that is cosine squared theta d theta, and we have the denominator of sine squared theta. Now, cosine squared theta divided by sine squared theta, that is equivalent to cotangent squared theta d theta. Okay, cotangent squared theta d theta, it has an equivalent identity again. So that is equivalent to cosecant squared theta minus 1 d theta. Let's distribute. Okay, so integral of cosecant squared theta d theta minus integral of d theta. Integral of cosecant squared theta, that is equivalent to cotangent theta, and the integral of d theta, that is theta plus c. This is our final answer for the trigonometric form. We will convert this one into an algebraic form since this is not valid as a final answer for this algebraic function. So we will be converting this back in terms of algebra. So how do we convert this one? Okay, let's begin constructing our right triangle right here. Okay, so notice we have the value x is 3 sine theta. What is sine theta? That is x over 3. Constructing our right triangle with this part right here as our triangle. Sine theta, this one it is the opposite x and the hypotenuse 3. Therefore the missing part right here, that is the square root of 9 minus x squared. Hypotenuse squared minus the other side squared. So notice this is familiar to you. This is already given right here. Square root of 9 minus x squared. Now let's begin with the value of cotangent theta. So cotangent theta, we all know that is adjacent over opposite. The inverse of the tangent. The inverse of the tangent. So if the tangent is opposite over adjacent, this one is adjacent over opposite. What is the adjacent? So we have the square root of 9 minus x squared. What is the opposite? We have x. How about for the theta? We already have the value of the sine theta right here. Theta is the arc sine. So for the theta, that is the arc sine of x over 3. Okay, so now replacing the value of our final answer from the trigonometric form into an algebraic form, cotangent, that is the square root of 9 minus x squared over x minus the theta is the arc sine of x over 3 plus c. This will be our final answer. Okay, so number 2, we have the integral of dx over the square root of 4x squared plus 1. Okay, again, assigning the values for a squared, obviously we'll use 1. For the a, that is 1. For the u squared, it's equivalent to 4x squared. Therefore, the u, that is equivalent to 2x. What shall we replace with u, or the 2x? So this is the function plus a constant, u plus a squared, so we'll use a tangent theta. Okay, the derivative of the u, the derivative of 2x, 2dx. What is our a? Our a is 1, so the derivative of tangent, that is secant squared theta d theta. Okay, so first we will be completing this one. We need to have 2 right here since we have 2. So let's correct this one with 1/2 integral of 2 dx all over with the square root of 4x squared plus 1. Okay, so let's have the trigonometric function. So convert this one in terms of trigo. 2 dx, that is equivalent to secant squared theta d theta all over with the square root of, what is 4x squared? So if we're going to square 2x, that is 4x squared. So we're going to square our tangent. Tangent squared theta, and replacing, we still have 1. Okay, so let's have 1/2 integral of secant squared theta d theta divided with tangent squared theta plus 1, that is equivalent to secant squared. Canceling this one. So now have 1/2 integral of secant squared theta d theta over secant theta. We could cancel another value of the secant theta. we only now have 1/2 integral of secant theta d theta. We've already find the value of this one in our previous topic, so that is equivalent to 1/2 ln of secant theta plus tangent theta plus c. This is our final answer for the trigonometric function. Let's convert this one in terms of algebraic function. Okay, so let's have the value of the one that we have substituted from the algebraic form. So we have 2x right here is equivalent to tangent theta, since our a is again 1. So tangent theta is clearly 2x over 1. So if we construct our right triangle right here, for tangent theta, this is opposite 2x, and this is adjacent 1, TOA. Therefore, this part right here, it's the square root of 4x squared plus 1. Familiar? This is our original function right here, the one that has the radical symbol. Okay, so the value of tangent, it's already given. Tangent theta is 2x. Let's just have the secant theta. The secant theta is known to us as hypotenuse over adjacent. So hypotenuse, the square root of 4x squared plus 1 over adjacent is 1. Therefore, we have 1/2 ln of, what is secant theta? The square root of 4x squared plus 1. What is tangent theta? 2x plus c. This will be our final answer. Okay, so let's try to solve problem number 3. Integral of dx whole over with quantity x squared plus 1, quantity raised to the power of 3/2. Okay, so 3/2 is again part of our radical symbol. We could illustrate this one in terms of radical symbol. We have dx over the square root of x squared plus 1 cube. Okay, so we will try again replacing this algebraic function with trigonometric function. Okay, a squared is obviously 1, therefore a is 1. We have the u squared as x squared. U is x. So what shall we replace with x? We have, since this is plus, a tangent theta. Again, if our a is 1, then this is just basically equivalent. X is just basically equivalent to tangent theta, since our a is 1. The derivative of x, the derivative of tangent, we have secant squared theta d theta. Okay, so now let's have dx right here, secant squared theta d theta, whole over with the square root of x squared. So we have tangent squared plus 1 raised to 3. Okay, so secant squared theta d theta, the square root of tangent squared theta plus 1, that is equivalent to secant. That is equivalent to secant. Okay, ito na lang i-show. Square root of secant squared theta, cancel, raised to 3. So we now have secant squared theta d theta over secant cube. Since this is already secant raised to 3, that is secant cube theta. Notice we could cancel 2 values of the secant, so we have a remaining secant from the denominator. Integral of d theta for the numerator, and we have secant theta from the denominator. Take the reciprocal, or let's just have the equivalent value of 1 over secant. 1 over secant, that is equivalent to cosine theta d theta. Integral of cosine theta, that is equivalent to sine theta plus c. Now this will be our final answer for the trigonometric form. Now we will convert this one back into an algebraic form by again constructing a right triangle based from our substitution right here. So we've known already that our tangent theta is equivalent to x. Again, we will be writing imaginary 1 so that we could trace up our right triangle. Our right triangle, we have tangent theta as the opposite x, adjacent as 1. Therefore, our hypotenuse will be the square root of x squared plus 1. Okay, since we're looking for the value of the sine theta is basically the opposite x over the hypotenuse, the square root of x squared plus 1. Now replacing our trigonometric answer in terms of algebraic, we now have x over the square root of x squared plus 1 plus c. This will be our final answer. How about number 4, evaluating dx over x squared, the square root of 9 minus x squared. Okay, so obviously we can see now where is our a squared. This is equivalent to 9. Our a will be 3. And our u squared is obviously x squared. U is x. So what shall we replace with x? Constant minus function. Let's have a sine theta. What is our a? We have 3 sine theta. The derivative of x, dx, we have 3 cosine theta d theta. Okay. So let's have the conversion. Dx is 3 cosine theta d theta. X squaring this one. So we now have 9 sine squared theta. The square root of 9 minus squaring this one again. 9 sine squared theta. The common value between the two terms is 9. Factoring that one out, the square root of 9, that is 3. 3 cosine theta d theta, 9 sine squared theta, and we have our 3 right here, and 1 minus sine squared theta. 3 cancel, so we have 1 over 9 as a constant outside. Cosine theta d theta, we have the sine squared theta. How about here? 1 minus sine squared, that is equivalent to cosine squared. Canceling the square root. So now we have 1 over 9 integral of cosine theta d theta whole over with sine squared theta cosine theta. We could cancel the 2 cosine thetas. So we now have 1 over 9 integral of d theta over sine squared theta. Take the inverse of sine, or let's have the equivalent value of 1 over sine theta. 1 over sine theta, that is equivalent to cosecant theta. So this is cosecant squared theta d theta. Okay. So the integral of cosecant squared theta, that is negative cotangent theta plus c. Okay, so this is our answer from the trigonometric form. So we need to again construct our right triangle based on our substitution. So we have x as 3 sine theta, therefore sine theta is equivalent to x over 3. Construct the right triangle. sine theta. This one it's the opposite, and this one that is the hypotenuse. Therefore, this missing piece right here will be hypotenuse squared 9 minus x squared. Familiar? This is from our original function. We have the square root of 9 minus x squared. Now let's have the value for cotangent theta. Cotangent theta is known to us as the opposite of tangent. So if tangent is opposite over adjacent TOA, therefore cotangent, that is adjacent over opposite. 9 minus x squared over x. Replacing the value of cotangent here, negative 1 over 9. The cotangent is the square root of 9 minus x squared over x plus c. This will be our final answer for this example. Okay, so number 5. Evaluating the integral of x whole over with the square root of x squared plus 6x plus 12. So notice, look at the algebraic expression inside our radical symbol. X squared plus 6x plus 12. So this time, the presence of this 6x. So we cannot directly assign this one as the a squared and this one as the u squared if we have this 6x. So we better use completing the square method. So notice we have done this one already in our previous video, how to complete square. We begin by assigning what is p of x. So x squared plus px plus c. So what shall we do with the px? What shall we do with the 6x? So we assign p, we remove 6. P will be divided with 2. 6 will be divided with 2. So that is 3. And we're going to square our p over 2. So this will be equivalent to p squared over 4. So in our case, 6 divided by 2 squared. 6 divided by 2, that is 3. 3 squared, we now have 9. So what shall we do? In our original algebraic expression, x squared plus px, we're going to add the p squared over 4 plus c and subtract the p squared over 4. So in our case right here, we now have x over the square root of x squared plus 6x. What is our p squared over 4? We have 9. Plus 9 plus 12 minus 9 dx. Okay, so we can complete this part right here, and we can also find the result from this part right here. We now have the integral of x whole over with the square root of, this one is obviously x plus 3 squared, and this one has a result of 3. Okay, so please remember our completing the square method. This is what we call as completing the square. Okay, let's erase this one. So now we can assign the value for our a squared and u squared. Our a squared is 3. Our a is square root of 3. Our u squared is x plus 3 squared. Our u is x plus 3. Okay. So what shall we assign here? Since this is plus a tangent theta. What is our a? Our a is square root of 3. So let's have u x plus 3, and this is square root of 3 tangent theta. The derivative of x plus 3, that is dx. Square root of 3, the derivative of tangent, that is secant squared theta d theta. Okay. So now, let's try to substitute this one to our algebraic expression right here. X, or dx, let's do not forget our dx. Our x, okay. So we have our x. So transpose this one to the other side. We have the x. So for the x, that is square root of 3 tangent theta minus 3. Okay, so that is the value of the x. So square root of 3 tangent theta minus 3. Now for the dx, we already have the dx, square root of 3 secant squared theta d theta. And do not forget, we have x plus 3 squared. X plus 3 squared, that is 3 tangent squared theta plus 3. Coming from here. Squaring this one, also squaring this term right here. Square root of 3 squared, we have 3. Tangent squared, we have the tangent squared plus 3. Okay. So let's try to simplify. Factoring out the common value, square root of 3. We have square root of 3 tangent theta minus 3. Let's have parenthesis. Square root of 3 secant squared theta d theta. Okay. So we now have square root of 3 factoring out the square root of tangent squared theta plus 1. Cancelling square root of 3, square root of 3. And now, which part should we erase? Okay, this part right here. Let's have integral of square root of 3 tangent theta minus 3. We have the secant squared theta d theta all over with, about here. This one is equivalent to secant squared theta. Cancelling this one out. Square root of 3 tangent theta minus 3. Secant squared theta d theta over secant theta. We could cancel. And now we have square root of 3 tangent theta minus 3 secant theta d theta. Okay, so let's erase this part right here. So integral of square root of 3 secant theta tangent theta d theta minus 3 secant theta d theta. Square root of 3 integral of secant theta tangent theta d theta minus 3 integral of secant theta d theta. Integral of secant theta d theta, that is secant theta minus 3 integral of secant theta, that is ln of secant theta plus tangent theta plus c. This will be our final answer for the trigonometric form. Let's convert this one to an algebraic form. Let me just erase this part right here. We have x plus 3 square root of 3 equivalent to tangent theta. What is tangent theta? That is x plus 3 over square root of 3. Let's construct the right triangle. We already have the value of tangent theta. This one, x plus 3 over square root of 3. How about for the secant? We only need for the secant. This is our theta. This one, it's the opposite, x plus 3. This one, it's the adjacent square root of 3. Therefore, this part right here is adding this one, square, and then the addition of this one. So we have x plus 3 squared and plus 3. Okay, so x plus 3 squared plus 3. If we simplify this one, this is the same as x squared plus 6x plus 12. Okay, so what is secant theta? Notice secant theta is hypotenuse over adjacent. Hypotenuse is this one, which is also equivalent to this one. Let's use this one. X squared plus 6x plus 12 all over with square root of 3. Okay, so now let's substitute this one and this one in our final answer right here. Square root of 3, what is secant? Square root of x squared plus 6x plus 12 all over with square root of 3. Cancelling. Minus 3 ln of secant x squared plus 6x plus 12 over square root of 3, and tangent x plus 3 over square root of 3 plus c. So simplifying, square root of x squared plus 6x plus 12 minus 3 ln of, we could combine the same base, square root of 3 square root of x squared plus 6x plus 12 plus x plus 3. This will be our final answer. Okay, so number 6, the integral of ln cubed w dw whole over with w the square root of ln squared w minus 4. So we will focus our attention to the algebraic expression that has radical symbol. So assigning again, what is our a squared? Obviously it's 4. Our a will become 2. And our u squared is obviously ln w squared. Therefore our u, that is ln w. Okay, so the construction of this algebraic expression is case number 3. We have here the function minus the constant. Therefore, we're going to replace this one with a secant theta. Okay, so what is a? We have 2. So u ln w, that is 2 secant theta. Deriving u, deriving ln u, recall the derivative of ln u, that is du over u. So this is dw over w to the derivative of secant, that is secant theta tangent theta d theta. Okay, so let's try to rearrange this one so that we could substitute. Arranging, we now have ln w cubed all over with the square root of ln w squared minus 4. We have the dw over w. What is ln w? ln w, that is 2 secant theta cubed all over with the square root of ln w again. We have 2 secant theta squared minus 4 dw over w, that is 2 secant theta tangent theta d theta. Cubing, we have 2 cubed secant cube theta all over with squaring 4 secant squared theta minus 4 multiplied here with 2 secant theta tangent theta d theta. Okay, factoring out common, which is 4 square root of 4, that is 2. 2 cube and 2, we have 2 to the 4th. Let's have second cube, and we have 1 right here, second to the 4th theta, tangent theta d theta, all over with factoring out 4 square root of 4, that is 2, square root of second squared theta minus 1. Okay, so let's continue on from this side. Integral of cancelling out one value of the 2. So this is now 2 cubed second to the 4 theta tangent theta d theta all over with second squared theta minus 1, that is equivalent to tangent squared theta, cancelling that one out. We now have 2 cubed, which is 8, second to the 4 theta tangent theta d theta all over with tangent theta. Cancelling that one out, we now have 8, second to the 4 theta d theta. We have cases right here, so we'll split that one with second squared theta and second squared theta d theta. Let's convert this one in terms of tangent. 8, we have tangent squared theta plus 1 second squared theta d theta. Okay, now let's distribute. Okay, so let's erase this part right here. So we now have 8 integral of tangent squared theta second squared theta d theta plus 8 integral of second squared theta d theta. Obviously, we could assign u here, the tangent theta, the derivative of the u, it is here, obviously, second squared theta d theta. Here we have the direct value of second squared theta d theta, that is equivalent to tangent. So now let's have 8, the form of u squared du plus 8 integral of the second squared theta d theta. U squared du, that is u cubed over 3 plus 8 tangent theta plus c. What is the u? 8 over 3, the u is tangent theta plus 8 tangent theta plus c. This is our final answer for the trigonometric. Let's convert this one back into algebraic. So let's have the algebraic. Let's use this one. Okay. LNW, that is 2 secant theta. Therefore, secant theta, that is LNW over 2. Construct the right triangle. When we say secant, that is hypotenuse over adjacent. This must be the hypotenuse, LNW, and this must be the adjacent too. Therefore, this part right here, that is the square root of the hypotenuse squared minus the adjacent squared, 4. Familiar? This is from our original function, the algebraic expression inside the radical symbol. So now let's have tangent. What is tangent theta? Tangent theta, it's opposite over adjacent. So let's have the opposite. Ln squared w minus 4 over adjacent, which is 2. Replacing. Here we have 8 over 3. Tangent cube, this is the tangent. We will cube this one. So square root of ln squared w minus 4 squared over 2 cubed, that is 8, plus 8. Tangent here is square root of ln squared w minus 4 over 2 plus c. Notice we can cancel 8. And the final answer will be, let's erase this part right here. So the square root of ln squared w minus 4 squared. So this is not squared. This one is cube. Sorry. Tangent cube. So cube. We have 1/3. And we have ln squared w minus 4 raised to the power of 3/2 plus, we now have 4 the square root of ln squared w minus 4 plus c. This will be our final answer. And that ends our video for the trigonometric substitution. Again, do not forget that after converting this algebraic form into trigonometric form, the final answer will be converted back to an algebraic form. And we will use the right triangle in the conversion.